Hello everyone, I am Abhishek KV, mathematics lecturer at Sri Ramakrishna Vidyashala, Mysuru. So, when it comes to KCET 2026 mathematics question paper, we already completed 20 questions from the first PUC topics. So, in this session, I am going to cover 5 chapters from the second year topics. So, the first one is relations and functions. They given 2 questions. Again, when it comes to inverse trigonometry, they given 2 questions. Again, when it comes to matrices and determinants, they given 8 questions from both the chapters. And when it comes to LPP, they given 2 questions from that. So let's start with the relations and functions of your second year PUC. Here, the first question, that is question number 34, version code B2. Here, they given, we have to find out the ordered pair which satisfies set of all ordered pair A and B, which satisfies A is equal to B minus 2. And here they mention B is greater than 6. When it comes to option A, we no need to check because B is less than 4 here. So we can directly cancel option 1. And when it comes to option 2, see A is 3, B is 8. This will not satisfy the given equation. So option 2 is not correct. When it comes to option 3, A is 6, B is 8. So this will satisfy the given equation. So option 3 is the right answer. Why not option 4? Because A is 8, B is 7. 8 is not equal to 7 minus 2. So option 4 is not correct. For question number 34, option 3 is the right answer. I hope you all got the solution for question number 34. So let's move on. When it comes to second question of your relations and functions of the second year PUC. So here the given function as f of x is equal to x plus 1 whole square. F of x is equal to x plus 1 whole square and x is greater than or equal to 1. And here they ask you to find out what is g of x, and they describe what is g of x. G of x is a function whose graph is the reflection of the graph of f of x in the line y is equal to x. Say, please remember, any inverse function whose graph is the reflection of the graph of the given function is in the line y is equal to f of x. So finding g of x is nothing but finding the inverse of the function f of x. That's all. Because all the inverse function, the graph of all the inverse function is the reflection of the graph of the function is in the line y is equal to x. You should know that. So here, to find f inverse of x, we should consider what is f of x. See, f of x is equal to x plus f of x is equal to y. We have to consider f of x is equal to y. And what is f of x here? X plus 1 whole square is equal to y. And our work is to find out what is x. See, x plus 1 become root y and x become root y minus 1. But the given options is in terms of x, so it will satisfy option 3. So I hope you all got the solution for relations and functions of the second PUC, and they given 2 questions. Okay, so let's move on to inverse trigonometric function. See, here in this particular year, again they asked 2 questions from ITF, but both the questions, please note this, both the questions of ITF, they given from deleted syllabus, from the deleted syllabus. So we have to wait what will board decide about these 2 questions. I think they should allot a grace marks to these two, to question number 36 and question number 37, because both questions are from deleted syllabus. See, let's get the answer for question number 36. So here the result is time saving result. See, you should know this to get the answer for this. Sin inverse x plus cos inverse x is equal to pi by 2. You should know this identity. So according to given, what they given? They given sin inverse x plus sin inverse y is equal to pi by 2. So if I take, since we have to find out x, so keep sin inverse x in left hand side. So take sin inverse y to right hand side. And according to this result, time saving result, sin inverse x plus cos inverse x is equal to pi by 2. Therefore, what it will be? Pi by 2 minus sin inverse y. It become cos inverse y. Now we have to compare sin inverse x with cos inverse y. See, and you should know sin inverse can't be cancelled with cos inverse. See, can I convert cos inverse y to sin inverse? How to convert one inverse trigonometric function to another inverse trigonometric function? See, if I consider the cos function, it is adjacent by hypotenuse. When I apply the Pythagoras theorem, so I will get the opposite side as root of 1 minus y square. So when it comes to when I'm going to convert cos inverse to sin inverse can be written as root of 1 minus y square divided by 1, because it is opposite by hypotenuse. Now I can cancel sin inverse with sin inverse. I am remaining with x is equal to root of 1 minus y square. Since they ask x square, so squaring on both sides, it become x square is equal to 1 minus y square. So option 1 is the right answer for question number 36. And don't forget, this is from the deleted syllabus. Let's see what the board will decide about this question. And when it comes to second question of ITF, that is question number 37, here also, this one also from the deleted syllabus, but see here the time saving result is trial and error method. Since the given equation is in series, matlab it is in sum. See, if I consider the first term, what is the first term? If I consider the first term, what it gives, tan inverse of 1 divided by 1 plus 2 is 3. See, for the given option, which of the following option gives tan inverse 1 by 3 for n is equal to 1, we have to check. See, consider option 1. Put n is equal to 1. What it gives? Put n is equal to 1 to the option 1. Tan inverse of n is 1, n plus 1 is 3. See, it will satisfy the option 1. But don't forget to check the remaining options, because 2 or more options will satisfy for n is equal to 1. That's why when it comes to option 2, if you put n is equal to 1, it become 1 plus 1 divided by 1. It will give tan inverse 2. So option 2 is not correct. Because we should get tan inverse of 1 by 3. When it comes to option 3, again it will give 1 divided by 2, but we want 1 by 3, so option 3 is also not correct. When it comes to option 4, if you put n is equal to 1, so it will give tan inverse 3, not tan inverse 1 by 3. So option 4 is also not satisfied. So option 1 is the right answer. Suppose if two options satisfies for n is equal to 1, then you have to take n is equal to 2 by taking sum of the two terms. See, sum of the two terms matlab from here to here. Okay. See, for n is equal to 2, what it will give? Consider option 1. Consider option 1. What it will give? Tan inverse of, for n is equal to 2. What it will give? Tan inverse of 2 divided by 2 plus 2 is 4. Again, it will give 2 tan inverse 1 by 2 plus tan inverse of, because we have to yeah, what we got? See, we got tan inverse 1 by 2. Tan inverse 1 by 2. See, if you are going to apply tan inverse A plus tan inverse B formula, we'll getting tan inverse of A plus B divided by 1 minus AB. That's why initially I told you this was from deleted syllabus. So if you are going to solve, we'll getting tan inverse 1 by 2. So no need to check from in this particular question, because for n is equal to 1, only option 1 satisfies the given equation. So option 1 is the right answer. Okay. So let's move on to matrices. See, here in this particular year they asked 3 questions from matrices and 5 questions from determinants. Sorry, 6 questions from determinant and 3 questions from matrices. So 6 plus 3, 9 questions they asked, and all questions are dead easy questions. Okay. See here, they given match list 1 with list 2. A matrix which is not a square matrix, then it is a rectangular matrix. A matrix with 3. All options having A with 3. Next, see, this is A. And when it comes to B, a square matrix A transpose is equal to A matlab it is symmetric matrix. So B satisfies 1 in list 2. So B1, where B1? See, option 2 we can cancel, option 4 we can cancel, because they are given B2, B4, and both option 1 and option 3 have B1, B1. Okay, so let's move on to C. The diagonal elements of a diagonal matrix are same, then we call it as a scalar matrix. See, if you know the definition of types of matrix, it will be easy for you, and no need to check for D in list 2, because since they given C2, C4, here it satisfies option 3, and obviously D is 2. See, a matrix which is both symmetric and skew symmetric, then it will be a null matrix. Then it will be a null matrix. So question number 51, option 3 is the right answer. So easiest one, if you know that definition of types of function, you'll easily getting the answer for this. So let's move on to second question in matrices. Very easy question. See, you will get the answer within 5 seconds. A row matrix has only one row with more than one column, with more columns. So one or more columns. So we call this is a row matrix. So option 2 is the right answer. Next, when it comes to question number 54, again, let X be a matrix of order. See, X be a matrix of order 2 by n, Z be a matrix of order 2 by p, and they given n is equal to p. What will be the order for 8x minus 9z? See, here the order will not change when I'm going to take a scalar multiplication or addition or subtraction. So it will be either 2 by n or 2 by p. Again, this was the question they have taken from NCERT textbook, and the particular question you can get it from Karnataka PU board question bank. So here either it will be 2 by n or 2 by p. Which of the following having 2 by n or 2 by p? See, we have 2 by n in option 1, so option 1 is the right answer. If they will give 2 by p, that is also correct, because n is equal to p they mention. Okay, again one more easiest question from matrices. So these are the 3 questions. One is from types of matrix, another one is from again types of matrix, and one more question from order of a matrix. That's all. So when it comes to question number 52, see, this is the question from determinant. They asked 3 questions. Sorry, they asked 1, 2, 3, 4, 5, 6 questions from determinant. So let's move on. So here statement 1, if A is a non-singular matrix, then A inverse exists. This is true. A inverse exists for non-singular matrix. What do you mean by non-singular? Determinant of A should not be equal to 0. Then we say A inverse exists. A and B are symmetric matrices of the same order. AB minus B is a skew symmetric matrix. This is also correct. See, we have a time saving result. If A and B are symmetric matrix, then AB plus BA is a symmetric matrix. AB minus BA is a skew symmetric matrix. So both statement 1 is true, statement 2 is true. So option 3 is the right answer for question number 52. See, when it comes to question number 55, which of the following is correct? See, determinant is a square matrix. Yes, determinant is a square matrix, but what is the definition of the determinant? See, determinant is a determinant is a number associated to a matrix. Yes, ultimately we are going to get a number associated to a matrix. Associated to any matrix is not possible. Determinant can be associated to a square matrix only. So when it comes to option 3, determinant is a unique number. Yes, associated to a square matrix. Determinant is not defined for square matrix. This is wrong. So option 3 is the right answer. The definition of determinant, see, very basic. Determinant is a unique number. Finally, we are going to get a unique number. It should be associated with a square matrix. Determinant can be defined only for square matrix. So option 3 is the right answer for question number 55. And see, the first question from inverse and symmetric and skew symmetric, and this is the mixture of matrices and determinant. And the second question was the definition of determinant. When it comes to third question, if A and B are invertible matrices of the same order, which of the following is not correct? They given. See here, A into adjoint A into A is equal to AI. This is wrong, because we know A into adjoint A is equal to adjoint A into A is equal to adjoint A into A, and this will be equal to determinant of A into I. Determinant of A into A. So option 1 is the wrong answer. So we can directly tick option 1 because this is not correct. And see, when it comes to option 2, A into adjoint A is equal to adjoint A into A. Properties, yes, this is correct. AB whole inverse can be written as B inverse into A inverse. This is correct. Determinant of A should be not equal to 0. Since A and B are invertible, it should be non-singular. Non-singular matlab determinant of A not equal to 0, determinant of B not equal to 0. So for question number 56, option 1 is the right answer because that is not the correct property. Okay, so when it comes to question number 57, again the question from determinant. If A and B are invertible square matrices of order n, then which of the following is not correct? See, determinant of AB can be written as determinant of A into determinant of B. So option 1 is correct. Determinant of Ka is equal to K power n into determinant of A, where n is the order of the matrix. Option 2 is correct. But determinant of sum of two matrices can't be write as determinant of A plus determinant of B. This is wrong. We can't write like this. So option 3 is not correct. But when it comes to option 4, determinant of A transpose is equal to 1 by determinant of A inverse they given. Yes, because determinant of A transpose is determinant of A. Again, determinant of A can be written as 1 by determinant of A inverse. 1 by determinant of A inverse. So option 4 is also correct. Option 3 is not correct. So that will be the right answer for question number 57. Question number 57. Yes, let's move on to the next question. That is the fifth question from say again one more easiest question. The area of a triangle with vertices 3, 8, minus 4, 2 and 5, 1 is P by 4. Then what is the value of P? See, you know area of a triangle half of 3, 8, minus 4, 2, 5, 1, 1, 1, 1, and they already given it is P by 4. Already given it is P by 4. And whenever they only given area, we have to take plus or minus. You should know that. So we have to find out what is the value of P now. Okay. So if I'm going to take half of, see, if I'm going to expand this along row 1, 3 into 2 minus 1 is 1, minus 8 into minus 4 minus 5 is minus 9, plus 1 into, see, minus 4 minus 10 is minus 14, and this is equal to P by 4. So we can cancel 2 ones are 2 2s are, it will remain with P by 2. So it become 3 plus 8 9s are 72 minus 14 is equal to P by 2. And 3 plus 72 is 75. 75 minus 1 is 61. 61. And this is equal to P by 2. This is equal to P by 2. And since we have to find out P, see, 2 ones are 2, 2 6 are 12. So answer is 122. Option 3 is the right answer for question number 58. One more easiest question, that is from area of a triangle using determinant. So the last question, that is the sixth question from determinant. Here the system of equation, see, you know ax plus by is equal to c1, a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. So here if a1 by a2 not equal to b1 by b2, then it will exist a unique solution. You know this unique solution. If a1 by a2 is equal to b1 by b2, if it is not equal to c1 by c2, then it has no solution. Then it has no solution. Here unique solution because both the lines are intersecting. Here no solution because both the lines are parallel. And when it comes to a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the lines are coincident. Then we'll get an infinite solution. Then we'll get an infinite solution. So let's see what is the answer for this. So this is the time saving result you should know. So here if you consider a1 is equal to 1, b1 is equal to 2 and c1 is equal to 3. When you consider equation 2, a2 is equal to 2, b2 is equal to 3, c2 is equal to 3. So when you're going to consider a1 by a2, it is 1 by 2. b1 by b2, it is 2 by 3. See here, a1 by a2 not equal to b1 by b2, so therefore it has unique solution. So option 2 is the right answer for question number 59. So if it is a1 by a3, this is the first result. Okay, so it has unique solution because both the lines are intersecting. Okay, so we'll move on to the last topic of the today's session, that is linear programming problem. Again, this was the question they given in KCET. This is the question from previous year KCET 2020. They given the question from KCET 2020. So here, a linear programming problem, the objective function has the same maximum at two corner points. The number of points at which z maximum occurs is what? See, you should know, if you consider any graph, this is the time saving result. If two lines are intersecting, see, if suppose this is your feasible region, suppose if you say A, B, C, if A and B gives the same maximum value, remember, if A and B gives the same maximum value, then throughout the line, see, from A to B, you're getting the same maximum value. Therefore, what is the answer? You have infinitely many solutions. If any two corner points having the same maximum or minimum value, please remember, then the number of points at which z maximum or z minimum is infinity. So option 4 is the right answer for question number 39. Question number 39. So we'll move on to the last question of the today's session. The corner points of the feasible region determined by the system of linear constraint are 0, 10, 5, 5, 15, 15. Again, the question from KCET 2019. Here, both the questions of LPP from the previous year questions only. So the relationship between P and Q, so that a maximum of Z occurs both points 15, 15 and 0, 20. See here, they given a px plus qy, px plus qy be the objective function, and here they mention the relationship of P. We have to find out the relationship between P and Q. The maximum value of Z occurs at both the points. Here, if maximum value of the Z occurs at both the points, then at 15, 15 it becomes 15p plus 15q, and since both are maximum, matlab same value, both are maximum, matlab same are both are gives the same value, and at 0, 20 it become 20y, it become 20q. See, 15p can be written as 20q minus 15q is 5q. See, 5 ones are 5 threes are. Therefore, the relationship between P and Q is 3p is equal to Q. 3p is equal to Q. So option 4 is the right answer. 3p is equal to Q. So option 4 is the right answer. So from this, we completed 33 questions, dear students. So we are remaining with 27 questions. So I'll meet you with few more questions from the few more topics. Thank you everyone. Love you all. Stay tuned. Take care. Bye bye. Namaste.